Today I'm looking at a Miteq U9796-6 KU-Band up converter. Based on what someone's written on the front, it's obviously a 70 megahertz in, KU-Band out. One of the things I need to check is to see what the full frequency range of this is. Typically these things will go from 13.75 up to about 14.6, 14.7. So that's one of the things that I intend to test today. Now let's take a look at it. On the back of the up converter we have various features. This is where we would connect an alarm directly to a computer, so if anything goes wrong the computer would be told. This other DB9 is for remote control. If you've seen my other videos, particularly with the CDM570 modems, you'll know that they're fairly simple to control. This is a monitor port. It's checking the output of the 70 megahertz input. When things go wrong, there are many reasons they could go wrong. One point being that perhaps the 70 megahertz is a problem and it's not getting a good clean 70 meg from the modem. And so by attaching a spectrum analyzer to that monitor port, you could at least determine that the input is clean. This is where you connect the input from the modem. And let's move across. And on the other side we have SMA connector for an RF monitor output. Again, we can monitor it here. The lower SMA connector is the part that you connect directly to the amplifier. So this should be the 14 gig KU-Band output. And in case you want to run an external reference, you can input it there. Now let's turn it on and start to look at it in detail. Okay, I've started to make some connections. I'm running a 70 megahertz cable from this frequency generator into the back of the up converter. And on the RF side coming out of the up converter, I'm running it into the spectrum analyzer. You can see the 70 megahertz input there and the output by SMA going into the spectrum analyzer so we can test the output. Now as I turn it on, I can see it's been set up as output of 14.5 or 14,500 megahertz with a straight input of 70 megahertz. Attenuation is 10 dB and TX is shown as on. Now the frequency generator is currently set up at some strange frequency, but the most important thing is the RF is currently off. And so let's go ahead and set up to 70 megahertz input. Okay, there it is. I'm going to turn the RF on. No, I'm not going to bother. First thing I have to do is turn the spectrum analyzer on. And I'm going to set the spectrum analyzer to look for 14.5. Okay, I've got 70 megahertz input. Let's set up the spectrum analyzer to, I think it's 14.5 gigahertz. Okay, there it is. Now, let me check. RF is off. Let me turn the RF on. Okay, I've turned the RF on. It's running at a very low signal strength, minus 59. So I'm going to gradually increase that at the same time watching the spectrum analyzer and seeing where the signal occurs. There it is, it's starting to sneak up some. Let me reset the span to 2 megahertz because this is typically a very low signal. It's a carrier wave, a CW. And it looks fine, and let me just look at the peak search, see what that looks like. Right, precisely at 14.5. So now I'm going to go back to the, I'm going to change the frequency output on the up converter and see if we can figure out how to do this. Menu. Okay, it seems that we're in the right place at the 14.5. Press enter, and I'm going to put in 13.785 and press enter again. As I look at the spectrum analyzer, although you can't see it, the signal has gone, so I'm just going to move to the spectrum analyzer now. Change the frequency to 13.785. Frequency 13.785 gigahertz. And there it is, it's back on frequency. So we know at least that this up converter will go from 13.785 up to 14.5 gig. And again, let me just check the exactly 13.785 on the KU-Band output. So this up converter seems to be working very well. So we'll wrap it up now and put it back on the shelf.